Polaris, also known as the North Star or Pole Star, has long been regarded as the guiding North Star and has held a revered place as a beacon for astronomers and navigators for centuries. Its steadfast presence in the night sky has been a cornerstone of celestial navigation, using the night sky as a guide. However, recent research presented by the esteemed Royal Astronomical Society in September 2023 has cast a shadow of uncertainty over the fate of this celestial luminary. The research paper reveals that Polaris is on the verge of exploding and forever disappearing from the night sky. This revelation raises important questions and implications that we must explore. Let's start by taking a closer look at Polaris itself. Polaris holds a special place in the sky due to its proximity to the celestial North Pole. It sits almost directly above the Earth's North Pole, making it appear nearly stationary in the northern sky. It is located in the constellation Ursa Minor, also known as the Little Dipper or the Small Bear. In terms of size, Polaris is a yellow-white supergiant star, considerably larger and brighter than our Sun, with a radius estimated to be about 40 times that of the Sun. It is often perceived as a solitary star, but it is actually part of a complex triple star system. The primary stars, Polaris AA and Polaris AB, appear as a single star to the naked eye, while a third companion, Polaris B, orbits the binary pair. The interactions among these stars create a gravitational pull, shaping their orbits and influencing their behaviors. One important aspect to consider is the distance between Polaris and Earth. Situated approximately 323 light-years away, the light from Polaris takes about 323 years to reach us. This means that the light we currently see from Polaris is as it was 323 years ago. If Polaris were to explode today, we wouldn't know about it until 323 years from now. This temporal delay adds an intriguing element of time to our understanding of the star's potential fate. Throughout history, Polaris has played a significant role in various cultures and civilizations, imparting cultural, navigational, and symbolic value. Its stability and fixed position near the celestial North Pole have made it an invaluable navigational aid for ancient mariners and travelers, allowing them to orient themselves and navigate across seas and lands. Polaris served as a guiding beacon amidst the celestial dance of the night sky, symbolizing constancy and steadfastness. In myths and folklore, it often represented guidance, stability, or a celestial anchor. Its fixed position in the night sky has also made it crucial for astronomers, serving as a reference point for observing other celestial bodies and aiding in the study of the night sky motions and patterns. Polaris is also a Cepheid variable star, which means it displays periodic variations in brightness. This characteristic has provided valuable insights into stellar properties, the nature of variable stars, and even cosmic distances. By observing the pulsations of Polaris, astronomers have been able to make important discoveries about the behavior of stars and calibrate instruments for measuring cosmic distances. However, in recent times, astronomers have noticed unsettling irregularities in Polaris's pulsation patterns. Instead of following a predictable pulsation pattern, Polaris has begun exhibiting an erratic and unpredictable cycle of dimming and brightening. This irregular behavior has baffled astronomers and prompted closer examination of this celestial anomaly. The deviations from expected behavior suggest that Polaris may be nearing the end of its life. The progressive elongation of Polaris's pulsation period, which was traditionally stable in its cyclic dimming and brightening, can be attributed to the interactions among the stars in the system. These interactions shape their orbits and influence their behaviors, including the luminosity and characteristics of the stars involved. Any disturbances in these interactions can lead to irregular variations in the star's luminosity or pulsation patterns. The exact mechanisms and intricacies of these interactions are not yet fully understood. While scientists have made predictions based on current empirical evidence, the possibility remains that Polaris may have already exploded, and we simply haven't seen the light from that event yet. Given the distance of Polaris, it would take 323 years for the light from any explosion to reach us on Earth. This means that by the time we witness the event, it would have occurred over 3 centuries ago. The irregularities observed in Polaris's behavior have prompted scientists to raise concerns about the star's future. The irregular pulsation patterns and deviations from expected behavior are consistent with the pattern observed when a star nears the end of its life. The annual increment in the pulsation duration stands at 4.5 seconds, which may not seem significant, but it is a big deal for astronomers studying these celestial phenomena. Some astronomers have suggested that the irregularities in Polaris's behavior may be the result of gravitational interplay between the Polaris stars, which could induce fluctuations in Polaris's atmospheric conditions, directly impacting its pulsation patterns. However, others are not convinced and believe that the star is on the verge of exploding in the near future. They argue that Polaris's enigmatic behavior bears striking resemblances to other stars that have exhibited irregularities in their luminosity before a potential imminent explosion. One exemplary stellar counterpart that has exhibited analogous irregularities in luminosity is Betelgeuse, an eminent star residing in the Orion constellation. The comparative analysis of Betelgeuse and Polaris unveils a fascinating correlation in their behavioral anomalies, particularly in terms of fluctuations in brightness and pulsation patterns. The resonance in these irregularities has prompted a heightened level of concern and vigilance within the scientific community regarding the impending fate of Polaris. The captivating parallelism between the behaviors of Polaris and Betelgeuse serves as a compelling foundation for experts to sound alarms regarding the potential transformative event awaiting Polaris. The acknowledgement of irregular behaviors in stars during their twilight stages is pivotal in comprehending the broader cosmic narrative. These celestial entities, despite pulsating rhythmically over vast epochs, manifest peculiar variations in luminosity as they traverse the concluding phases of their stellar odysseys. NASA's proactive engagement with the anomalies witnessed in Betelgeuse exemplifies the scientific community's discernment of the significance of such irregularities. The agency's profound interest and vigilance underscore the potential insights that can be gleaned from closely monitoring stars exhibiting behaviors akin to those observed in Polaris and Betelgeuse. In stark contrast, the concerns raised by astronomers regarding the irregularities in Polaris's behavior have yet to be officially formalized through a public announcement of escalated scrutiny and apprehension. Despite this, the global scientific community and enthusiasts of celestial observations would undoubtedly be captivated by the prospect of Polaris undergoing a supernova event. The hypothetical scenario of Polaris going supernova remains a source of fascination, potentially paving the way for groundbreaking discoveries in the realm of astrophysics. As scientific curiosity intertwines with the allure of cosmic phenomena, the enigma surrounding Polaris and its irregularities further fuels the collective interest of researchers and stargazers alike. If Polaris were to go supernova, it would likely be a spectacular event in our sky. The star would suddenly become incredibly bright, potentially outshining the moon and becoming one of the brightest objects in the night sky. This brightness could last for days, weeks, or even months. The appearance of the star might change drastically, transforming into a brilliant point of light or a transient object, possibly developing colorful hues before fading away. Such a visual display could temporarily alter our perception of the familiar pattern of the Big Dipper or Ursa Minor, as Polaris is the current North Star and a part of these constellations. The potential repercussions of a Polaris supernova on Earth, while comparatively less significant than a closer supernova event, remain a subject of scientific intrigue. Despite the greater distance, the supernova's luminosity would render it visible to the naked eye for an extended duration, outshining nearby stars and captivating the attention of astronomers and observatories worldwide. While the specific impact on Earth's atmosphere and surroundings would be diminished compared to a closer supernova event, the global scientific community would undoubtedly be fascinated by the celestial spectacle unfolding in the night sky. Turning our attention to the star itself, a critical inquiry arises. What would be the post-cataclysmic fate of Polaris in the event of a supernova? It is imperative to recognize that Polaris lacks the requisite mass to culminate its stellar journey in a supernova explosion. Instead, as it exhausts its nuclear fuel, the star will undergo a transformative process, shedding its outer layers to metamorphose into a white dwarf, a diminutive yet exceedingly dense stellar remnant. This serene transition marks the conclusion of Polaris's stellar evolution. Delving into the potential aftermath of Polaris's burst engenders profound scientific curiosity and inquiry. Drawing parallels with historical supernova events and smaller burst events yields invaluable insights into the potential evolutionary stages of resulting celestial remnants. Rigorous analysis of light curves, spectra, and remnants from these events becomes instrumental in predicting the distinctive characteristics of Polaris's anticipated burst and discerning its impact on the surrounding celestial environment. This comparative approach facilitates a comprehensive understanding of the celestial dynamics at play during and after a supernova event, shedding light on the intricate processes governing the evolution of stellar remnants. As the scientific community embarks on this exploration, the anticipation of Polaris's potential supernova event becomes a catalyst for advancing our understanding of the broader cosmic context. The collaborative efforts of astronomers worldwide, leveraging observational data and theoretical models, contribute to unraveling the intricacies of stellar evolution. The enigma surrounding Polaris's fate post-supernova underscores the importance of continued research and inquiry, driving the quest for knowledge about the celestial phenomena that shape our universe. Scientists examine the differences in mass composition and speed of ejected materials between Polaris's anticipated burst and other observed events to assess the formation of nebulae or distinct elemental distributions. This comparative analysis helps predict and contrast the potential outcomes of Polaris's upcoming event within the cosmic context. By examining the mass, metallicity, and evolutionary paths of stars in the pre-supernova stages, scientists can gain insights into potential disparities or similarities in their explosion mechanisms. However, despite meticulous observations and extensive analysis, the irregularities observed in Polaris's behavior remain a perplexing puzzle. Predicting exactly when a star's life will end is no small matter. The enigmatic nature of Polaris's irregular pulsations calls for deeper scrutiny and investigation. Astronomers recognize the imperative need to delve into the underlying mechanisms responsible for these unprecedented behaviors. Unraveling the unique conditions driving Polaris's irregularities holds the key to advancing our comprehension of stellar evolution and behavior. Polaris emerges as a celestial entity of paramount significance within the realm of astronomical pursuits, assuming a pivotal role as an unwavering reference point for both telescopic calibration and celestial navigation. The potential catastrophic event of Polaris undergoing a burst adds a layer of substantial concern for the future of astronomical observations. The recent revelations emanating from the Royal Astronomical Society underscore the imperative for heightened scrutiny and comprehensive research in this specific astronomical domain. Astronomers grapple with the intricacies surrounding Polaris's irregular pulsations, recognizing the critical necessity to unravel the unique conditions precipitating this anomalous behavior. The hypothetical loss of Polaris as a pivotal reference in the nocturnal expanse would exert a profound impact on the precision of ground-based telescopes and celestial measurements. This potential absence would necessitate a meticulous recalibration of instruments and prompt a thorough reassessment of our existing comprehension of the intricacies of the night sky. The contemplation of Polaris's potential loss underscores the magnitude of its role within the field of astronomy, representing an irreplaceable cornerstone that contributes significantly to our understanding of celestial phenomena. In considering the ramifications of Polaris's absence, one must acknowledge the multifaceted implications on astronomical research and navigational accuracy. Ground-based telescopes heavily rely on Polaris for calibration, and its loss would demand innovative strategies to compensate for the void left in observational precision. Celestial measurements, intricately tied to Polaris's positional stability, would necessitate a paradigm shift in methodologies, urging astronomers to adapt and devise alternative reference points. Moreover, the potential repercussions extend beyond the scientific community, reaching into educational spheres and practical applications. Polaris's role as a guiding light for navigators would be compromised, necessitating adjustments in traditional navigation techniques. This underscores the pervasive impact of a Polaris burst, not only within the scientific community, but also within broader domains where its absence would be acutely felt. In response to the inherent uncertainties surrounding Polaris's fate, collaborative efforts within the scientific community become imperative. The coordinated endeavors of astronomers worldwide, utilizing cutting-edge technologies and observational methodologies, contribute to the ongoing elucidation of the celestial dynamics governing Polaris. The need for an exhaustive understanding of the unique conditions leading to its irregular pulsations underscores the necessity for sustained research initiatives. In conclusion, Polaris stands as a celestial beacon of paramount importance, with its potential burst prompting substantial concerns within the astronomical community. The recent revelations from the Royal Astronomical Society accentuate the urgency for intensified scrutiny and dedicated research efforts. The hypothetical loss of Polaris would reverberate across diverse facets of astronomical endeavors, challenging our methods of observation, navigation, and understanding of the cosmos. As astronomers grapple with the complexities surrounding Polaris's irregular behavior, the pursuit of knowledge remains a steadfast guiding principle, propelling us toward a deeper comprehension of the celestial phenomena that shape our universe.